some geometrical problems. Okay. Now here I don't need to give you any theory, but there are certain questions which are asked. Okay. Let's say I ask you this question. There is a chessboard. There's a chessboard. Okay. We all know in a chessboard there are 8 rows and 8 columns. Correct? Okay. My question is, in a chessboard, how many rectangles are there? What are the number of rectangles in a chessboard? Who will tell me? Now, some of you would be already knowing, you may have done it in junior classes. Squares are also counted under rectangles only, don't worry. Squares are also rectangles. Very good, Pranav. Pranav has cracked it. See, all of you please see the structure of a chessboard. Okay. So I have drawn some lines here. Okay. Now I think I have made a chessboard for you. Okay. Let's count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Now, in order to pick up a rectangle from this, now rectangle can be of various shapes and sizes, right? But in order to pick up a rectangle, think as if this entire chessboard is made by laying these sticks. They're red sticks like this, or you can say vertical red sticks. And there are yellow sticks laid in a horizontal fashion, right? So think as if this entire chessboard has been obtained by laying these sticks. Okay, so there are these red sticks and there are these yellow sticks. Okay, in order to make one rectangle, you have to choose a pair of red sticks and you have to choose a pair of yellow sticks. Why I'm saying a pair of? Let's say I pick up this red stick and I pick up this red stick, and I pick up this yellow stick and I pick this yellow stick, then automatically this rectangle will be chosen. I hope you can see it on your screen in between, correct? So in order to choose one rectangle, you need a pair of red sticks and you need a pair of yellow sticks. Am I right? Now, how many red sticks are there altogether? If you count, there will be 1, 2, 3, 4, 5, 6, 7, 8, 9 red sticks are there. If you pick any two out of them, and similarly yellow sticks will also be 9 in number. If you pick any two out of them, then these many rectangles will be formed, which basically comes out to be 36 into 36. 1296 rectangles are there on a chessboard. Okay, these results are very well known. Any serious JEE aspirant will remember this result. Tell me how many squares are there on the chessboard. Don't say 64. There are more than 64 squares in chessboard. How many squares are there on the chessboard? Okay. Now the squares, no worry, Aaron. Yes, Pranav is correct. Now, in order to make a square, absolutely, Madhav. In order to make a square, your squares can be of various dimensions. Correct. So let's say if you want to make a dimension 1 by 1 square. Okay. Let's see how many squares are there. Number of squares. See, if you want to make a dimension 1 by 1 square, you have to pick up two consecutive sticks from the red ones and two consecutive from the yellow ones. Correct? That means either I can pick these two or 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 these two. So if you count, it will be 8 pairs coming out consecutive. 1, 2, 3, 4, 5, 6, 7, 8. So pick any one of the 8 pairs from the red ones and any one of the 8 from the yellow ones. That also will be 8C1 only. So your total number of squares will be 8 into 8, that is 64. That you can actually count also. 1 by 1 dimension squares will be 8 into 8, 64. Okay. But why I told you like this is because then you will be able to calculate other dimension squares. For example, 2 by 2, you can say it is 7C1 into 7C1. Why 7C1 into 7C1? Because let's say now you have to pick up two such sticks which are at a distance of at least one stick apart. For example, if you can pick up these two, you can pick up these two, or 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 you can pick up these two. So 1, 2, 3, 4, 5, 6, 7. Out of the 7 pairs, you can pick one pair. Similarly, here also in the yellow ones, out of 7 pairs, you can pick any one. So 7C1 into 7C1. So 49 squares will be there whose dimension will be 2 by 2. Correct. Similarly, 3 by 3, it is 6 square, 36. And if you keep on doing this, 8 by 8 dimension will be 1 square, which is 1. So your answer would be total number of squares will be 1 square, 2 square, 3 square till 8 square. This is nothing but n into n plus 1 into 2n plus 1 by 6. I don't know whether you are aware of this formula, but I keep on using this so that, yeah, this is the formula that anyways we are going to do later on. So this will become around, this is 72. So 12 into 17, which is 204 squares. Okay. So on a chessboard, there are total 204 squares. Got it? Okay. All right. Now let's do a question. Let's say each of these boxes is a square. Okay. Each of these boxes is a square, even though it might not look like one. So there is a 3 by 4 structure like this. Find the total number of rectangles. Okay, don't sit and count it. And second, find the total number of squares. Find the total number of rectangles and find the total number of squares. Remember, all squares are also rectangles. Okay. Very good. All right. So the first part answer is Now remember, in order to make this structure, you need four horizontal, or you can say four vertical sticks, and five horizontal sticks. So in order to make a rectangle, you have to choose any two from the vertical one and any two from the horizontal one. So your answer will be 10 into 6. There will be 60 rectangles. Is that fine? There will be 60 rectangles. Okay. How many squares will be there? How many squares will be there? To make a 1 by 1 square, okay, you can choose any of these three. So let me write second part. So to make a 1 by 1 square, you can choose any one of these three. So 3C1 and any one of these four. So 4C1, correct? To make a 2 by 2, remember for 2 by 2, you can choose any one of these 1, and similarly here 3C1. And to make a 3 by 3, you can choose like this. Remember, 4 by 4 cannot be made. So your answer will be 12 plus 6 plus 2. That is nothing but 20 squares will be there. Is this fine? Aditya, absolutely correct. Madhav, absolutely correct. Rests. Pranav, 120. From where? Yeah, 120. Okay. Next. Next question that I would like to ask you is, okay, let's go back to our chessboard. Okay. There is a mouse over here. There's a small mouse over here. Okay. Which is at this point of the chessboard. Okay. This mouse can only move right or up, and that too by 1 unit each. Okay. So you can go 1 unit either to the right or 1 unit to up. He cannot go back. He cannot go down. He cannot go, yeah. He cannot go left. He cannot go down. So he can only move right or up. In how many ways or how many paths can the mouse choose to reach this point? Starting from this point, let's say A point, he has to reach B point. He can only move right or left, and that to 1 unit at a time. How many ways can he reach from A to B? How many paths can he take from A to B? Two to the power number of intersections. Absolutely correct, Aditya. Good. Aditya has got it. Okay. This is not a difficult question. If you think very clearly, I mean, with a very, I can say, calm mind, you will understand that ultimately to reach from A to B, he has to move 8 units right and 8 units up. Correct. So think as if moving a unit right is like R and moving a unit up is like U. Okay. So now he needs to arrange 8 R's and 8 U's among themselves. Okay. So the number of ways in which he can go from A to B is like, how many ways can you arrange these 8 R's and 8 U's among themselves? Correct. So let's say if you arrange it like R, R, U, U, means he's going right, right, up like that. Correct. So ultimately to reach from A to B, he has to move 8 units right and 8 units up somehow, in whichever fashion he wants. Correct. So the order in which he can choose R and U is up to him, but he can only choose 8 R's and 8 U's to go to B. Correct. So the number of ways in which you can arrange 8 R's and 8 U's among themselves is the number of paths he can take. So your answer would be 16 factorial by 8 factorial 8 factorial. You can also say 16C8. Is this fine? Any questions? Any questions? Any concerns? Okay. Now I'll complicate this question. I'll give this as a homework to you. Let's say this mouse has to go from A to B and this grid is broken over here. Okay. Let's say this mouse has to go from A to B. Same mouse, same characteristic. He can only move right and up, and that too by 1 unit. And now there is a hole over here. That means this path is broken. Now how many ways can he go from A to B? Please do this as a question and do let me know the answer. White is divided by 8 factorial 8 factorial. Madhav, the answer to this is how many words, how many 16 letter words can you make from 8 R's and 8 U's? How many 16 letter words can you make from 8 R's and 8 U's? So you have 16 objects, out of which 8 are identical of type 1, 8 are identical of type 2. Won't you divide by 8 factorial 8 factorial? Arey, that is why I said arrangement, na? Order matters, of course it matters. That is why I said arrangement. Okay, so treat this as a question for your homework. I think I have given you 3 questions so far to think on. All right, let's take a few other questions. Okay, let's take this question. There are 10 points in a plane, out of which there are 10 points in a plane. Out of these points, no 3 are in the same straight line except 4 which are collinear. Question is, how many straight lines can you make from this? There are 10 points in a plane, out of which 4 are collinear. How many straight lines can you make? Part 1 of the question. First answer part 1, then we'll go to part 2, 3 and 4. Just a second, guys. I believe I've taken the attendance. Yeah, I've taken it. First part done. Any answers? Anybody? Madhav, you are correct. Gayatri, no. See, in order to make a line, you need 2 points, right? And you have 10 points. So if I choose any 2 out of 10, I'll get 10C2. But here is a catch. I have got 4 points which are collinear. Collinear means they're in the same straight line. That means 4C2 would be an overcount because these will not contribute 4C2 lines. This will only contribute 1 line because these 4 are in the same line. So if I take any 2 of them, this or this or this, they're all considered to be a part of the same line. Line is an infinitely extending geometrical figure. Correct. So in this 10C2, 4C2 are those cases which will not contribute to 6 lines. They will only contribute to 1 line. So you subtract this and add a 1. Why subtract this? Because these are overcountings you have done. So you need to discount your answer by 4C2 because they will contribute to 1 line and not 6 lines. So you remove the 6th line, but you add a 1 because they will contribute to 1 line. not 6. So ideally you should reduce by 5. That's what I'm trying to say. Got the point? This question you would have done in school also. Come on. This is the very commonly asked school question. Yeah. Anyways, I should have done this with NCR only, but I thought I would keep the geometrical questions towards the end. Next is, how many triangles can you make? This is easy. Absolutely, Madhav. 10C3 minus 4C3. Right? So if you take any 3 points out of 10, 10C3 points will 10C3 triangles will be formed. But remember, these 4, they will not contribute to any triangle because they are in the same line. So 4C3, that is a extra count that has come in the scenario. They need to be excluded from the answer. Absolutely correct. How will you choose 3 lines from those 4? They are on the same line. No. What if the 3 lines are parallel? तब क्या करोगे प्रणव? They will not contribute to a triangle. Get the point? Or 2 are parallel, 1 is cutting each other. Okay. So you had a good idea, but it will fail because of this constraint. Last one. How many quadrilaterals? How many quadrilaterals can be formed? Okay, very good, Madhav. Guys, can you calculate your answer and tell me? Because I just have the final answer with me. So I can check whether your answer is right. Okay, Aditya. Aditya, the book says 185 for some reason. I'm not very sure whether they are right or you are right. So I'll also work along with you. Okay. Let's see if my answer matches with them or yours. The book says 185. Okay, let's discuss it. We are only running short of time. See, you can get a quadrilateral if you pick up the 4 points from the other 10 points, from the other 6 points. So 6C4 will definitely be your answer, will be in your answer, right? So there are 6 such points which are, of which no 3 are collinear, right? So if you pick up any 4 of them, one quadrilateral will be formed. Am I right? Yes or no? Okay. Oh, Madhav got the answer. Okay. Okay. Now, another way to get it, if I pick 1 from here and the remaining 3 from the other 6, correct? Or if I pick 2 from here and remaining 2 from the other 6, correct? Remember, I cannot pick 3 from here. If I pick 3 from here, I'll get a triangle. Okay. So the total number of ways should be this, as per me. This is going to be 15. This is going to be 80. And this is going to be 6 into 15, 90. Oh, 185. Absolutely correct. Is this fine? Any questions, any concerns? Oh, you had a different method. What method was it, Madhav? Would you like to share with us? Or you took the total cases and subtracted from there where a quadrilateral is not possible. Okay. That's fine. That's fine. So dear all, with this we put an end to our very long chapter. But this is very important for your KVPY point of view also. So now that you have done this chapter to such a great depth, you should not get stuck in any KVPY questions. So